To do the next step, we're going to need to have our radio turned on and bound with the model so that we can go in and determine what switches we want on the radio to activate what modes and different elements inside of Inav. So to do that, very simply, you need to decide which switches on the radio you want to use, whichever ones are comfortable for you, and whichever items inside of the modes that you want to use, and then assign them to the different switches. What you may choose to set up could very well be slightly different from what I'm choosing to set up, but I'll go through exactly what I've done and basically how I've done it. And then from there, you'll be able to make your own decisions about what you may or may not need. So on my radio, I typically have this 2-position switch set up as my arming switch. And on the opposite side, this particular switch I use for a beeper and at the same time, the pre-arm switch. So those two I use for the arming and beeper. This one here, it's a 3-position switch. I'm simply going to use it for the navigation modes. And so when it's at this point, there's no specific navigation mode going to be in play. In here, it's going to be loiter. And at the top, I'll set it to be return to home. The switch over on this side, it's again a 3-position switch. At the bottom position, I'm going to have it set up for being in manual mode. In the middle position will be acro mode, and at the top will be horizon mode. And those are flight modes. And then the only other switch I have is this particular one here, which I'm going to set up as the as the switch for auto tune and level tune. But basically in this position, the lowest position, nothing is happening. In that position, it will be the auto tune, and in the top position like that, it will be the auto level. So let's go through the process of setting these up. It's not particularly difficult. Do make sure that your radio is turned on when you're doing that. So here we are now again in Inav, and we're on the modes tab. And this is where we're going to be able to set up the modes that we want and associate them with the switches on the radio. I've already done a few here. So you can see that, for example, if I flick the switch that I've chosen to be the arm switch, it moves, and you can see that it activates. And the same with the pre-arm, does the same thing. And you can see that momentarily the beeper flashed because they're associated with together the same thing. And the different flight modes, I've got one set up in the lower position here as being the manual mode. When I switch it to the middle, there is no mode selected, which means it will be an acro. And then if I take it to the highest level here, it will go into the horizon mode. The other ones that I had mentioned earlier, including the flight mode and then the auto tunes, I haven't added them in here. So let's go ahead and add those in right now. Now I'm going to click this off so we can see the ones that we haven't used yet. And we'll just scroll down and we can see here that one of the ones I said I wanted was loiter, and I'd like it to be assigned to this particular switch. So I'll add a range and come here, choose auto, and then choose the switch that you want to use, and it will activate. Where I want it to be is in the middle position, is where I want nav loiter to be. And then in the top position is where I want nav return home to be. So again, I'm going to add range, and I can see that it already is channel 9, so I'll just switch it over to channel 9. And this bar here indicates the active zone. And so if I take it again, you'll see the switch, and it will now become active in navigation return to home. And so now we know that this particular switch here will, in the middle place, give us the loiter, and at the top position, give us return to home. The other thing we need to do down here is we're going to come in and we're going to add in these auto-tune things that are specific to fixed wings. And these are processes or systems that Inav uses to help set up its own trims inside the system. So what we're going to do is we are going to add in an auto-tune range, and we'll switch it here to auto, and I'll choose this switch here. and it's the middle place that I want to be auto-tune. We'll add range, and again, it's channel 8, we already know. Switch to 8, and I would like auto level to be when this switch is in the uppermost position. We come back up here now and we hide these unused modes. We can see that we've got a fair number of things set up here. So having made all of these changes, make sure you come down and hit save. From here, what we need to do is we need to go in and check the outputs and make sure that the motor is spinning properly and that the radio is talking to the servos properly and that they're moving in the right directions and stuff like that. So just give me a moment while I change here what I've got under the camera. And to do this, I'm just going to slide it in. You will need to have a LiPo and connect it to the system. So I'm just going to do that right now. And you'll get the startup chirp like that, which is just fine. The first thing that we are going to do, and I apologize for this right off the top here, I don't physically have the space to put everything together, to have both wings on my desk and the camera and show you how to do this. So I'm going to be doing this with only one wing as a demonstration. When we go through these remaining steps here, you really should be doing this with both wings attached completely. When we come in here to the Outputs tab, you're going to need to, first of all, enable motor and servo output. If you have started up your system here, you've plugged in your LiPo, and all you're getting is a beep, 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 and a repeating sort of every 2-second kind of beep, that means that you've got an ESC protocol selected that your ESC doesn't recognize. Because we're working with a flying wing and not quadcopters here, you'll always be safe just to use standard. So just choose standard. Stop motors on low throttle. This is another place where you can turn that on or off. Make sure it is turned on. And these two settings here, the idle power and the throttle scale, just simply leave them as is. Now what we want to be able to do is test the motor to make sure that it's spinning the correct direction for our propeller. On a propeller, there will be some writing that shows you the size of the propeller and maybe even the brand of it. Knowing where that is, that tells you that that's going to be the front of the propeller. When I put it on the back, I need to make sure that it's facing forward because the propeller spins and moves the airplane this way. And so it needs to be spinning this way, which means my motor needs to spin in this direction. So what we have to do is we just have to activate the motor and see if it is spinning the correct direction. No, you don't need to have your propeller attached to do this. In fact, it's better if you don't. And so all you need to do is come over here with the propeller off, click here that you understand the risks, and simply activate the motor. And what you'll do is, once it's been activated like that and it's spinning, just very gently touch it with your finger and you will be able to feel the direction that it's rotating. So we'll do that. Okay, and I can tell that my motor here is spinning the wrong way. So what I need to do is fix that. And the easiest way to do that is to come into your compartment here and simply change 2 of the ESC plugs. Just swap one to the other and you'll be good. Don't do that when you have your LiPo plugged in. Okay, so what we're going to do here is actually I'm going to unplug the LiPo, which will deactivate that system. And I'm going to, sorry, this is a little tricky for me to do on the camera. Unplug 1, unplug 2, and then just swap them. There we go. Okay. Managed to do that somehow or t'other. Put that back in. LiPo is unplugged still, so we'll plug that back in. And then we'll come back here and try that again. And just like that, Now the motor is spinning the correct direction for my particular prop. So you'll need to do that for yourself and whichever prop direction that you have to make sure that it is spinning the correct direction. The other thing we want to do is just come down here, and with our radio, we can move the joysticks, and we want to make sure that the control surfaces are moving, and they're moving the directions that we expect them to. Now, this is why you really need to have both wings attached so you can see what's happening to both. And so we're seeing that everything is active and working properly. So we'll just make sure that we have saved all this in case we've made any kinds of changes. From here, we need to go down to the PID tuning tab. And this is a fairly important step prior to the first flight. What we need to do is we need to make sure that the feed forward settings are high enough with our radio when we are in manual mode would be full throw, maximum distance, and then when we switch it into the acro mode, it would reach 80% of that, more or less. Okay, and the way we do that is by adjusting on inside of Inav the feed forward values for each of the axis, pitch, and roll. And then what you will do is quite simple. You will make sure that with your radio, you are in, like I've set up on mine, manual mode. Then you will take to a full stick deflection, and then you will switch to the other mode. And if you can see, as I do it, it's very hard to tell, but there is a slight change in position on that. Now, what you need to do is make sure that it is enough. And so if I take this, here's the pitch, I'll go backwards, it may be easier, and switch, you can see there's a change. Now I'm just going to, inside of Inav, really drop this down. I'll save it, and you'll see that suddenly when we switch from, it's hard for me to do, when we switch from acro, from manual to acro, that difference is monstrous, and that's way too big. And so if when you start off, your throw between the two changes that much, that is too much, you will need to come in and adjust the feed forward. And I can't remember where this is at. This is roughly at 100, I think. I'm just going to put it at 100 and save and see if that makes a difference. And you can see it did. It doesn't change nearly so much. And from maximum to acro is about 80%. And so what you will need to do for your particular model is for each axis, adjust the feed forward value so that when you're doing your pitch from manual to acro is about 80%. And when you do your roll, that from manual to acro is about 80%. That can take a little bit of fiddling back and forth and take a couple of iterations of doing it, but that's the basic steps. Now, the only thing that will be different for you when you do it, and compared to me as I'm demonstrating it, is that you will have both wings attached and be watching the changes on both elevons as you are making these adjustments. Having done all of those things and you're happy with that, make sure you hit save. The rates in Expo will come in here. Initially, we are going to leave the roll, pitch, yaw, rate, everything that's in here as it is. They're very docile rates. They'll be very soft, safe rates to fly with. But what will happen is during the auto-tune process, Inav is going to start to realize and learn what pitch, roll, and yaw rates it can actually handle, the model can actually handle, and will start to adjust them automatically for us. So for initial flights, we'll just leave these as they are, and they'll be taken care of for us during the auto-tune process. Having done all of this, let's come down here to the Advanced Tuning tab. Now, in the Advanced Tuning tab, there are a few things for us to take care of. First of all is the auto launch settings. Now, auto launch is something that is very, very useful, but the settings for fixed wing auto launch are very, very specific to the model that you're flying. How much it weighs, how much thrust it can generate, and as simple as changing a prop from an 8x5 prop to an 8x6 prop will change the thrust and can have an effect on how well all of these settings work. So realistically, you need to be fairly careful with these at the beginning. If it's your very, very first flight ever, you don't know exactly the settings that are appropriate for your model. If your model is, again, if you put a bigger battery or a smaller battery in it, the auto launch settings will change simply on the total weight that's in the model. So be careful when you're using these. Okay, well, let's just go through them quickly so you have an idea of what they're about. The throttle delay is basically how long does it take from when you raise your throttle until the system realizes it's in the auto launch system. Maximum throwing angle is the maximum angle it will take as being acceptable for a throw. 75 degrees is fine for a wing. The motor delay, that is from when you're throwing it till it realizes it's been launched, and that is 1/10 of a second. Minimum launch time. This is basically the minimum amount of time that Inav will take to do the auto launch process. If you set this to 0 and you touch a stick on your radio, it will cancel the auto launch. By putting in a larger value like 2000 milliseconds or 2 seconds, the auto launch will continue working regardless of what you may do or bump or hit accidentally for that full 2 seconds. And so that's a reasonable thing to allow it to activate, do its thing, take off, and take control. Motor spin up time. This is basically a gear safety thing. If you, unlike in a quad where we often will just just spank the throttle and hit it really, really hard, really, really fast, or when you hit it really hard like that, it's hard on the system. It dumps a ton of current into the ESC and into the motors, and it's hard on them. And it's way better if they can just kind of get a ramp up to that speed, in a very short period of time, but over time. And so typically 200 milliseconds, which is 2/10 of a second, not very long, okay, is pretty reasonable for something like an 8 or 9 inch prop. Okay, it gives it enough time to kind of get going without really whacking the system, the ESC, too hard. The launch throttle, if it's your very first time taking off with a plane, it's a little bit of a guess because you don't really know, based on the dynamics of your plane, what it weighs today, exactly how much throttle it's going to need to become airborne and stay airborne. And so this here, 1700, is basically a 70% throttle. So that's a pretty reasonable range to be in for most planes. If you don't have enough, you'll get not enough power and you'll nosedive. And if you have too much, you can do a straight up and drop tail first. So you want a happy medium in there. For an initial one, 70% throttle is probably going to be fine. Climb angle, is how steep it's going to go up. Fairly reasonable at 25, kind of range. 20 degrees could be acceptable as well. And then the others are just timeouts if you decide not to. Like if you just wait around, it's not going to do anything. Transition time is a dead zone between when the auto launch stops and the other navigation mode takes over. Whether you choose to use auto launch on your first flight, your maiden flight, will be entirely up to you. But those are the settings that you will need to be aware of and set. On the other side here, we have these navigation settings. Initially, I would say just leave these as they are. We don't really know what our cruise throttle is going to be or any of these kind of things that is going to be suitable for the long term. As initial settings, these will be just fine for cruising and navigation. The remainder of these, we can just kind of bypass for right now. Generic settings down here, we have the return to home settings. So that's if you activate the return to home feature. And I'm going to choose at least, and then the return to home altitude is going to be, in my case, 50 meters. The return to home altitude is what you will be when you actually get back to the home base. Now, I'm making a flying wing here, and so I'm going to want it just to keep going around and around in a circle above me. We can set up a 2-stage return to home, and if we do that, we would activate this climb before return to home. If we have this as on, what will happen is the model will at first go up to the designated height and then turn and return to home. If this is set to off, what will happen is the model will simply turn towards home and begin flying towards home and climbing at the same time towards the home and the desired altitude for the return to home. It's totally up to you what you choose to do. In my case, I don't need a 2-stage return to home. I'm flying out in huge open fields. I'm not going to have trees anywhere around me. If it came home at 20 meters off the ground, it's not going to be an issue. So for me, this is just fine. I'm not going to use any track back. This is if you have waypoints like that, and same with all of these. So we'll just leave those for now. On the other side, we're not going to be doing automatic landing with a flying wing. Initially, we're not doing any navigation waypoints, and we're not doing any general navigation at all. And so, having done that, save and reboot. Now we have done basically all of the different settings in here that we needed to do. And if we come over here and look at this pre-arming check, we can see they're all checked off and everybody is happy. It's got a LiPo in there right now, and we can see that it's reading those details properly. 46% battery is correct. This is not a fully charged battery. We can see that I've got 8 satellites connected, and it's a 3D fix. And if we come over here to the GPS, oh, there's 9, and we can see that it's all working. So the basics are now set up for us to be able to go out and fly, more or less. There are still a few things that we need to do in terms of the physical setup for the model, specifically making sure that it's balanced properly and setting up the center of gravity. And so for now, we can just disconnect here from Inav and also from over here on the system, and we'll get into taking a look at how we figure out the center of gravity and making sure it's balanced.